We're going to compute the limit of the partial sums to determine whether the series converges or diverges. We have 1/2 plus 1/4 plus 1/8 plus ... plus 1 divided by 2 to the power of k plus ... for our infinite series. So let's write this as our n, then we're going to write our term, and then our partial sum. And we just have the first three terms here. So let's write this as 1, 2, and 3 for the number of terms. So our first term equals 1/2. So our partial sum is just going to be the sum of your first term, which is just 1/2. All right. Now for the second one, we're going to get our second term is 1/4. So that means the sum of our first two terms equals 1/2 plus 1/4. Now that equals 3/4. Now what I'm going to do is write this as, for the 1/2, I'm going to write this as 1 minus 1/2. And for this one, I'm going to write this as 1 minus 1/4, which is 1 minus 1 divided by 2 squared. All right, now for the third term, a sub 3, we have 1/8. So we're going to add the sum of our first three terms. The sum of the first two terms was 3/4 plus 1/8. And that's going to give you 7/8. Notice here that equals 1 minus 1 divided by 2 cubed. So basically we had 1 minus 1/2, 1 minus 1/4, and 1 minus 1/8. And then I just changed this to 1 minus 1 divided by 2, 1 minus 1 divided by 2 squared, 1 minus 1 divided by 2 cubed. So when you look at that, we can see that our first sum equals 1 minus 1/2 to the first power. Our second sum is 1 minus 1/2 squared. And our third sum equals 1 minus 1/2 to the third power. Therefore, we can assume, after three terms, that our kth term is 1 minus 1 divided by 2 to the k power. So then let's take our limits, because we've got to see if this converges. So we're going to take the limit as n approaches infinity of the sum of our first n terms, which equals the limit as n approaches infinity of 1 minus 1 divided by 2 to the nth power. All right, so this is a constant. This is 1 minus. Now, when you substitute in a large number here, this number is going to get smaller and smaller, because you're going to have 1 divided by 2 to the nth power. So as your denominator gets larger, this number is going to get closer to 0. So that's 1 minus 0, which equals 0. Since the sequence of partial sums converge to 1, the series converges, and the sum of the series is 1. So we'll just write converges, and sum of series equals 1. Thank you. Have a nice day. Bye-bye.